Hello math lover, see you again on this video. Today we're going to discuss the following problem. We want to find an explicit bijection from n cross n to n, or vice versa, whichever you like, whether from n to n cross n or from n plus n to n. Okay. So first of all, we're going to list all elements of n cross n in the following manner. So first of all, the n that we use, the notation is the number, the positive integer. So some other people use n for the number non-negative integer. So some people use it starting from 0, 1, 2, and so on. But on this video, we use the notation n for all positive integers. So we're going to list all elements of n cross n as follows. Okay, 1, 1, 1, 2, 2, 1, 1, 3, 2, 2, 3, 1, 1, 4, 2, 3, 3, 2, and then 4, 1. Okay, so what is the pattern of this structure? Okay, so first of all, the first number is the smallest. We can think of as the smallest sum of all elements of n cross n. So if you look at element of the form a comma b, we look at the sum of a plus b. So the sum can be any number starting from 2, right? So this element is the only member of n cross n whose sum is equal to 2. And these two numbers are the only two numbers whose sum is equal to 3. Okay. So on each level, yeah, say this is level 1, this is level 2. On level 1, the sum of the two components is 2. On level 2, the sum is 3, and so on. So on level I, let's say here, on level I, we have the sum to be equal to I plus 1. Now let's look at how many numbers on each level, right? So on level 1, there is exactly one number. On level 2, there are exactly 2, level 3, exactly 3, and so on. So, and on level I, we have exactly I numbers. Okay. And then, the way we map each of these elements to n is basically how we enumerate all of these numbers. So we will enumerate in the following way. So let's call this to be our first number. So explicitly that means that we create a function f from n cross n to n such that f 1, 1 is equal to 1. And then the next number is this one. Okay. So once we finish a level, we enumerate the number on the next level starting from the left. So after 1, 2, 3, this is 4, 5, 6, and so on. So how do we exactly map a general a comma b? So let a comma b to be an element in n plus n. Okay. So first of all, we need to know this a comma b is on which level. Okay. Let a comma b is an element on the ith level. What does it mean? it means that the sum of A plus B is equal to I plus 1. Hence, A plus B is equal to A plus 1. Okay? So if we have a number, let's say here, 3,2, okay, 3,2, where the sum is 5. So if we look at the first number, that number indicates this element is, what is the order of that element? So like this one is 3, which means it's the third number on this level. If it is 3 here, then this element is the third element on that level. Okay, so if we have A comma B and A plus B is equal I plus 1, it means this A comma B is the 8th number on this ith level. Okay? Okay. So then, in order to know this number is mapped to which natural number, so we need to count all numbers. Let's say we want to know this 4,1 is mapped into what number. First we count all numbers here on the previous level, okay? And then after that we count this is to be what is the order of this element from the level. Okay, so for this one will be mapped to there are 6 elements on the previous level, and then this guy is the 4th element on that level. So it means this guy is gonna be mapped into what? 6 plus 4 will be 10, right? So with that description in mind, then we define A plus B to be. So first count how many elements on the previous levels. All elements on the previous level, which means all elements on the 1 up to I minus 1 level. So they're going to be 1 plus 2 plus I minus 1, right? That these are the number of elements on the previous levels. And then this A comma B is the 8th member of the number in the ith level. So this plus n, which means we have half of I minus 1 times I plus n. But I is exactly A plus B minus 1, so this is I minus 1. 1 half I, A plus B minus 1, times A plus B minus 2 plus. Okay, so we claim that this map given by this, so claim f from n plus n to n given by A comma B is sent to half of A plus B minus 1 times A plus B minus 2 plus A is a bijection that we are looking for. Okay. So first let's check that this map is injective, or which one is it? Injective or subjective? Let's say we want to check that it's injective, right? So suppose A comma B, C comma D is in n plus n such that f A comma B is equal to f C comma D, right? So it means that half of A plus B minus 1, A plus B minus 2 plus A is equal to half of C plus B minus 1 C plus B minus 2 plus C. Okay. So we would like to conclude that from this equality, it implies that A must be equal to C and B must be equals D. Okay. Remember that this map is exactly telling us the element a comma b is on which level and on and the member is the eighth member of all elements in the same level as a comma b, right? So with that information in mind, so first of all, we would like to say that at least in order f a comma b to be equal to f c comma d, then we need a comma b and c comma d is on the same level, right? So, which means that we would like to conclude from this equality that a plus b must be equal to c plus d, right? Okay, so in order to do that, let's look at the function, right? G from n to n given by k is half of k minus 1, okay? And well, you can see that g of k is increasing, right? You can look at the derivative of the function half x times x minus 1. But another way is by computing the difference between g of k plus 1 minus g of k. So what is the conclusion that we want to say here? Then gk is increasing. Okay. So to look at that, let's compute the difference between g of k plus 1 minus g of k. It's going to be half of k plus 1 k minus half of k times k minus 1. You can factor out the half of k, so it's times k plus 1 minus k minus 1. It's going to be 2, so that is k, okay, which is greater than 0 since k is in n. So not only g of k is increasing, we know also g of k plus 1 minus g of k is k. Okay. And now, by using this lemma, from this equality, let's call it the star equality. So we have, this is g of a plus b minus 1, half of g a plus b minus 1 plus a is equal to half of g c plus b minus 1 plus c. Okay. So first of all, we want to say that a plus b must be equal to c plus d. Suppose that a plus b is greater than c plus d. Okay, so then we have half of g a plus b minus 1 minus half of g c plus d minus 1 plus a minus c is equal to 0, right? It is equal to 0. Or we can move this a minus c to the left hand side, so we have c minus a is equal to that. C minus a is equal to that. Okay. Now, since a plus b is greater than c plus d and the g function is increasing, so g of a plus b minus 1 is greater or equal to g of c plus d plus 1, right? So a plus b minus 1 will be greater than c plus d minus 1. Okay? So it means a plus b. Yeah. What I would like to say that this g of a plus b minus 1 is bigger than g of c plus d, because a plus b minus 1 is greater or equal to c plus d. So if we subtract 1 here, so because a plus d is greater than what? Greater than c plus d, then a plus b minus 1 is greater or equal to c plus d. Okay? So therefore, since g is increasing, this is going to be greater than, I'm sorry, we don't need the half anymore, right? Because by definition, the g is already including this 1/2. So, okay. Alright. So c minus a is greater than g of c plus b minus g of c plus b minus 1. And according to the lemma, g of k plus 1 minus g of k is equal to k. So this thing is equal to c plus d minus 1. Okay? So therefore, minus a is greater or equal to, hence, so from the inequality that c minus a is greater or equal to c plus d minus 1, we have minus a is greater or equal to d minus 1. Okay? And this is a negative number, and d minus 1 is always non-negative. So then 0 is bigger than 0, which is a contradiction. So what do we learn from here? What we learn is that it is impossible to have a plus b greater than c plus d. So a plus b must be equal to c plus d. Okay? So from here, and a plus b is equal to c plus d. If a plus b is equal to c plus d, then this guy is equal to that guy. Therefore, a is equal to c. Hence, a is equal to c. And then, because that a is equal to c, then certainly b is equal to c. Okay. So therefore, thus AB is equal to CD and F is negative. Okay. Now we are going to show that G is, also F is surjective. What we need to show is that for every element here, we need to find an element of n cross n such that F map that element to the element that we chose here. Okay, so take M in n. Our objective is to find a comma b such that FAB is equal to m. Right? So since G, the G that we defined before from something like this, I guess, k minus 1, yeah. This is increasing. Okay. And G is taking value from 0. Yeah. So starting from 0. So we claim that there exists k, since g is increasing, then m will be between some g and g of k plus 1. Right? So because like for example we have g1 and g2 and g3. Okay? So if we have natural numbers, then the natural numbers will be lined up in between gk and gk plus 1, right? For any n. Okay. And if you want, you can make this claim more explicit. Yeah? So you can try to supply the argument why there is such case, such that m is between gk and gk plus 1. Okay? Okay, if m is equal to gk, okay, what does it mean? If m is equal to gk, which means half of k times k minus 1. Remember, this number is the sum of all elements on the level less than the kth level. So we have one number on the first level, two numbers on the second level, and then on the k minus 1 level we have k elements, right? So this number indicates that we count all elements from the first level up to the k minus 1 level. So if the value of g of k is exactly equal to this, then we are looking at this element. This is the gk element, right? So what do we want to see then? So this number then is equal to half of k minus 1 times k minus 2 plus k minus 1. Okay? We can check that if we factor out k minus 1. Okay? So we have okay, let's check. This is half of k squared minus 1 half k. And this guy is half of k minus 1. This is k minus 1. Half of k minus 2 plus 1. Which is k minus 1 times half of k. Yeah, exactly that number. Okay, so we have this. Okay. So if m is equal to g of k, then this g of k can be written in this form, but this one is exactly f of 1. Remember that this is the a, right? f of a comma b is like this. Right? So that number is the a. So the a is k minus 1. So this is f of k minus 1, comma 1. Right? Okay. Okay. We can check that if we take a to be k minus 1 and b equals to 1, that's exactly this number. Okay? So it means that m has a privilege, right? Now if m is equal to g of k plus some s, right? Because the difference between g of k and g of k plus 1 is k, then s is less than k, right? So if this is happening, then m is equal to half of k times k minus 1 plus s. Okay, so this is our A here, our A. So this is the same as 1/2 of what? S plus k minus s. S plus k minus s minus 1 plus s. So this is exactly f of s comma what? If it is a plus b minus 1, then s comma k plus 1 minus s. Okay? You may check that if we use a equals s and b equals to k plus 1 minus s, then f s comma k plus 1 minus s is exactly this number, and this number is exactly n. So therefore n is has a preimage, and therefore f is surjective. Okay, so it's a little bit longer as I expected. So thank you for watching. See you again in the next video. Bye.